Hello, good evening, everyone. Uh, so, this will be a revision session of week 1 to 4 of statistics 1 for DAD qualifiers. Right. I sent a link in the chat, which will be of this session. So, after this session will be over, you can, if you want to watch the recorded session or any of your friend wanted to watch this recorded session, they can do it. Okay. Um, Yeah, one more link I have, which oh, this. So this another link is there. If you open that, you can see previous term question papers. So I mean, there is not. You won't see specifically any question paper for, let's say, DAT qualifier. But what you can relate to is like statistics one course is there, foundation course. End term, if you see, end term has all the questions from week 1 to 12, similar to yours questions. Um, it just you all have different kind of weightage. You have all the weeks similar weightage, and they have higher weightage from week 9 to 12. So you can kind of, let's say, collect it from quiz one, quiz two, and term. You can just solve this, right? So if any topic you wanted, maybe you'll find questions from there which are previously asked uh, in statistics one course, but you can relate to that. Okay. Uh, on that, we can start the session. So I'll share my screen. Uh, yeah, any questions you can ask. Sure. So I'm sharing my screen. So yeah, so week one is there. In that, uh, generally we talk about what kind of variables are there. So so there are four kind of variables, which are nominal, ordinal, interval scale. Sorry, this is not variable. Variable are two kind. Either they are categorical or numerical. Okay, these are scales of measurement. This is scales of measurement. So how do you measure a column, right? So if a column is given to you, let's say name is there, age is there, let's say their body temperature could be there, right? So how do you classify this columns? You can classify it in either four of this, right? So interval, and the last one is the ratio, right? So if you see any data which has words in it, right? Not numbers, but words in it, name, like name, right? And they don't have any order in between, like one is not higher than or lower than anything, right? This is like generally we found, right? Name is one kind of nominal scale. So these are nominal scale where there is no order, right? No order. Then there could be order in between, let's say size of cups, right? Of any shop you go, like so there's small, medium, large, there's a uh, order in between. Education has order, let's say a student is graduate, uh, he's a bachelor, masters, doing PhD, something, right? So this kind of data has order in it. Interval scale is something which has order, but it doesn't have any reference as zero. So what does it mean by reference zero? So let's say something is there, some variable, any variable you can take. Let's say age you can take, or let's say income, anything you can take. If at zero means empty, like nothing, like that variable is vanishing at that point, right? I mean, it doesn't exist at that point. Let's say zero age. Nobody has zero age, right? If that means it doesn't exist, right? Let's say income, right? So zero income means there is no income, right? So when you can say no income, no age, something like that, uh, those kind of things are actually ratio scales. I mean, no age, no income, something, right? But what kind of scales? There are few others which doesn't vanishes at zero, right? Uh, which can go beyond zero, or below zero. Below zero can go, like let's say temperature could be, let's say, -3 degree, right? -3 degree, -4 degree, or something which doesn't have zero at all in that. Let's say credit score is there. That credit score, I think, starts from 300 and goes up to 700. There is no zero in between, right? So zero is why zero is important, because zero gives a reference that zero is there, right? You can double a number. If you have zero in it, then you can double it. You can do addition. You know what is the reference point, right? So this all four kind of scales are there. So to start with, we can have these questions which you can solve. uh, okay, so let's see. Yeah. So which of the following statements best describes the population sample? Okay, so this is not on that. First, mm, give me a minute. Yeah, here. Okay. Uh, yeah, this one. So let's say courier service is there, is interested in knowing customer feedback, right? The customers are being given the following options to choose from, right? So feedback is given to them in this way. So I mean, this is the feedback, right? So you can see this is not numbers. So they come under categorical. And in categorical there are two types, right? So either they can be nominal or they can be ordinal. Now we can see that this kind of data is uh, does have order, right? I mean, not satisfied, satisfied is kind of lower than or higher than in any order. You can see them, but they don't have like uniformity, or you can't say that they are not in order. There is some order in it, right? Somebody says, I'm neutral about it, I'm satisfied with the product. So that means he is positive about the product, right? You can think like that. So there is a order in between. So it comes under ordinal data, right? This come under ordinal data. Okay. Now, uh, okay, yeah, fine. Okay. Next thing is, what is the population and what is sample? So anything you want to study about is a population. And since we can't collect all the data about the thing I want to study, so what I do is I take a sample of it. Like so let's say you want to study about uh, let's say literacy rate of India, right? Literacy rate of India. That's what you want to study about. And you know that you can't collect all the people's literacy rate, right? I mean, you can't go to each and every person. Uh, that is kind of not possible kind of thing. Even if you do, it is very costly. So 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 we can't always do it, uh, right, in most of the cases. So what we do is we take small samples of each area. Wise we can go, maybe we can go district wise, maybe we can go state wise. Depends on how much deeper uh, study you want to do, right? So let's say if you go state wise, we can you can go to each state and then search few students, few people, not student, few people, and then ask how much educated you are, right? So they'll give some kind of information about their education, and based on that you can decide what is the literacy rate of India, right? So this the whole thing was population, that I wanted to study about the literacy rate of India, but I can't do that for the whole country, but I can do it for the small samples which I collected from different parts of the country, right? So you don't have to collect all of them, but you have to collect few of them from each state, right? So what you do, you'll go to, let's say, uh, Jammu Kashmir, and then collect, 1,000 student, 1,000 people. Then you go to, let's say Arunachal Pradesh, right? Arunachal, and then again you collect 1,500, any number, like, this just have to be greater than some value, right? Generally we take 30, but like, uh, you can take any number, okay? More than 30 is a fine number. Then you can go to Punjab, and then collect again a few more. So this will become your sample, right? You likewise you will collect maybe all of the states, few of the states, right? So depends on how is it. So generally what we consider is, we when we collect, which kind of study is, we if it's a mix of different kind of uh, representatives of a unit, then we consider that this is a good kind of sample, like it's not a bad sample. Like, let's say if I go to just J&K, Jammu and Kashmir, and then I take my data, and then that's all. Like that is my sample, and I study on that, and say that the whole population or whole India is studied this much, or literacy rate in India is this much. Then that's not a good sample, right? So if I collect a few more states, let's say 10 to 15, then it might become better sample, right? So it depends on how good you collect and all, right? So generally, inclusion of uh, different kinds of varieties in a sample is a good sample. Okay. uh, so now let's see, which of the following statements best describes the difference between population and sample, right? So sample is the entire group, while population is the subset of the sample which is used to describe. No, right? Population is the entire group, and sample is actually subset, right? So this if this was population, then we take some subset of it, which is sample, right? So this is not correct. Sample, population are synonyms to each other. This is also not correct. We can see from this. Population is the entire group, while sample is subset of the population, which is used to describe the parameters of the population, which is correct, right? So sample is coming from the population, and sample is the one which going to describe the population about, right? So this is correct, and okay, since this is correct, we consider this correct, right? Now let's see this question. So yeah, let's say a study has been conducted to examine whether the students who had applied for this exam in 2020 are willing to write the exam in the coming week or not. So exam is about to be in the next week, or in coming few weeks. So they wanted to take a survey. A group of 10,000 students were randomly selected from urban areas of India for the study. It is concluded that roughly 80% of the students want to write the exam based on the given information. Answer this. So exam is about to happen, right? And to decide how many people will write this exam, right? So maybe they need some kind of facilities for them or something, right? So to conduct this exam, so they conducted this survey, and what they took is they took urban population or urban people, uh, yeah, a group of urban students, right, who lives in city of 10,000. So sample size is good. Sample size is good. We can say that, right? And they said that 80% of this, maybe let's say 8,000, were willing to write the exam. Okay. So there is one issue, right? That they took only urban people. Uh, I mean, like I said, if you are taking a popular, or if you are taking a sample, it should represent a good amount of variety, right? It doesn't have that much variety. Like urban people are writing the exam, and most likely, if you see, city centers are in urban cities, not in the rural areas, right? So, and rural people have difficulty. They have to maybe travel more to the exam center, and they are more likely, we don't include them in the survey, we most likely not get the best results, right? So what we'll do is we can see that this is not a good sample, but let's see what are the statements given on this population and sample, right? The sample consists of students from all across the India, and population consists of students from the urban area. That this statement itself is reverse, right? I mean, if population consists of whole India, then it would have make sense that sample is smaller of that. So it doesn't look correct at all to me. The sample consists of students from the urban areas. This is correct. So this statement is correct. Sample consists of students from the urban areas, and the population consists of students all across the India. Uh, okay. Um, okay. This looks uh, little okay, right? So, urban sample measure students from the urban areas of India, and the population consists of student across from all across India. Okay, the sample consists of students from the urban areas, and population consists of 10,000 selection. This is not correct, right? So, population is the uh, student who are about to write the exam, right? So this is not correct. 10,000 is not the population. Population is actually the whole thing, right? So exam is about to happen, and who are going to write the whole India. We have to take as a population. Sample consists of 10,000 students. Okay, this is correct, from urban areas of India, and population consists of students from all across India. So I mean, uh, this is also okay. Okay, ma'am. Yeah. So yeah, this statement is okay. This statement is also okay. This two are not okay. But if you see, this is more correct, right? I mean, the sample consists of students from the urban areas of India. Here, the sample consists of selected 10,000. The, 10,000 students from the urban area, right? So I mean, this is more correct. We try to collect from the urban areas, but we didn't collect all of the urban students, right? I mean, that is not the whole set, right? That all the students from urban areas are correct. We did collect it from urban uh, sample of that, but we collected 10,000 only, right? So that's why this is also incorrect, right? Uh, okay. Identify the correct statement from the following. Aforementioned conclusion made on the basis of sample is correct. Conclusion is not correct because the sample is not good representation of population. Sample is good representation. So you can see this is incorrect. That sample is a good representation. Like I said, that we are not considering the rural uh, people, rural population while doing this study. So this is not correct. Um, conclusion. Uh, conclusion made on the basis of sample is correct. That yeah. So the conclusion is actually this: 80% of the students want to write the exam, right? So since we didn't collect the best sample, and we are saying it from this not good sample, that 80% of students will write. So we kind of gonna fail the study, right? This conclusion which we made, that 80% of people are going to write the exam without even considering a major group of rural. How can we make a judgment about that, right? So that's why this is also incorrect. And we can say that aforementioned conclusion is not correct because sample is not a good representation of population. So if you would have collected the whole population, I mean, we have considered the whole population, and then we would have collected the sample with a good representation of urban and rural students, and then we would have said that 80% of students are going to write the exam. Then that would have been the best scenario, right? And that would be in the correct study. But here, that's why this also incorrect study. Okay. Uh, so actually, I'm taking the question because I hope you would have seen the lecture videos. So you know this thing little bit here and there, and now and I'm we are just taking the question based on that, right? So what can you say about the nature of the study? What is it? Is it a descriptive or an inferential kind of study? So so when we take a sample, right, and so let's say this is a sample, and we study about that. We find, let's say, average, uh, median. So this is a study, right? We can say that averagely this will happen. 80% of the student will write this exam, right? The whole of that, right? So this kind of study are uh, can be doable, right? So studies can be doable. That this conclusions we can make. So if we study pop sample, and we make any kind of judgment, any kind of information about this. Since we have this, right, we concluded this, like I have the sample. I know everything about it because I have the data. This data is available to me, right? That's what the sample is. That I have the availability. So so I what I can do is I have the data. I can describe it. Right? I can describe my data, right? Uh, but I don't need to take inference about it. Inference is something we make a kind of judgment about it or something. Why I want to make an inference when I have the data, right? So when I have the data, when I have the data, uh, I don't make judgments, right? But so if I have just the if I have the whole population, right? If I have the whole population, then I don't need to make inference, right? But in our case, we don't have the whole population. What we have is we have the sample of 10,000 students from urban area, which are representing a population. So population is there. Out of that, 10,000 is a sample, and based on this study, this the study of this 10,000 people, I am saying that the whole population of that 80% are not going to, are going to write the exam. Sorry, 80% of the whole population are going to write the exam. So I took a sample, I studied that, and based on this small sample, I'm making a judgment about the bigger thing, right? So bigger mass. That is what inferential study is, and that's what we are doing here. Inferential, though this is like because we didn't collect the best sample, that's why this study will not be fruitful. But this is the type of study we are doing. Okay, so inferential kind of study we are doing. So let's say, like, if somebody asks, uh, let's say, how is Europe? We wanted to take a judgment about Europe. Is it a good place to go for a traveling or a trip, right? So what you can do, you can maybe ask few people that you went to Europe, right? How was it? They might say good, bad, something they would say. Then you might search few people on internet and then say that, okay, how is Europe? And you kind of say, right, that this is based on this people whom you collected to make your judgment. You make inference about Europe, that yeah, Europe might be a good place or a bad place based on this people, or internet you search about that. It's a good place to live. So this is called inference. If you go to Europe, you are in the Europe, right? You traveled it. Now you are making a judgment. That is not inference. That is like you are describing Europe, right? So now you will just describe the Europe, right? That this is how Europe was. It was good, bad, whatever you felt, you'd say, right? So we make inference when we don't have the actual data about it. So a sample of it we have. So we make a judgment about that, right? And this is how it's going to be like there. Okay. Uh, so That is that. Uh, yeah. So somebody was asking in chat that can I get recordings? Yes, you can get. So this. Uh, yeah. So I pasted a link that will be uh, this session's link. So after the session is over, you'll get this on YouTube. Yes, recorded. Okay. Now what is this? Karthik wants to start a shoe company, shoe production company for all Indian market to analyze public preference. He hires a team of market researcher who conduct market research in two states, Andhra Pradesh and Maharashtra. The market research team prepares a form to collect the data, and the collected data set is shown in this table, right? So this table is there based on given information. Answer question 5 and 6. Okay, let's see first the data. So we just now study scales of measurement, right? We can do something. Let's just try what kind of scales are there. So questions we can take it, but what kind of columns are they going to be? Generally, we don't do any kind of scaling, or we don't say any scales for a serial number. Serial number is just a number, right? We didn't collected this actually. This is what we get, like we just wrote in this way, this manner, right? So this is not actually data starts from here, right? That you collected this data. So name is there. Name you can consider as a nominal, right? Because there is no order in between. Age you can consider as a ratio scale because there is x0 as a reference exists, right? So this is a ratio scale. Shoe material. Now, does material have any like any order? Like let's say rubber is greater than synthetic or leather or something. Like generally we don't have any order of this, right? Nobody has it. So this you can also consider as nominal scale. This was what is it? The purpose of this, right? So purpose is different. Like all the purpose are equally you can say considerable. So here we can say this is also nominal. So this is also nominal scale. And price range, like yeah, like here we can see a order between, right? That low range is going to be price, right? Lower price, medium price, or higher price, right? So there is a order in between. So this is a ordinal scale. Now what is this? Is there any scale of measurement available here? No, right? There is no order here. This all are like unordered data. This is called unordered data because when the data is present in a form of like something, right? So when you know what is going to come next, right? Let's say this options are there. You know that something of this is going to appear in the this, right? So what you know what is going to be shoe material. There are certain limited options you have available in shoe material, right? In age also you know that certain numbers will appear, right? That integer will appear most likely. Integer will appear that 37, 25, 38, 99, 100, right? One, maybe more than 100, few, but you know that this kind of things are going you are expected, right? So this all you can actually give a scale to, but this is unordered data. So there is no scale here available for this, right? There is no scale on this. Now let's see what is the yeah. So they're asking which of the collected data is unstructured. Oh, okay. You can maybe say this is unstructured data as well, right? So this is a structured data, rest of them, but this is unstructured. So there is no unordered is actually little different, right? There's no order, but this is unstructured. You can say there's no structure that they follow, right? So what is it? Suggestions, right? Which is yeah, suggestion is the unstructured data. In order to forecast tomorrow's temperature in Mumbai, uh, this was it supposed to be two question. Hmm, could be maybe some mistake, but let's see. This is different question because now we are collecting different kind of data. So in order to forecast tomorrow's temperature in Mumbai, the India Meteorological Department collects the temperature, humidity, and rainfall data of Mumbai for all days from the past 3 months. What kind of data is this? This is time series data, right? You know that we collect data. If we are going to collect this thing for past 3 months every day, then it is going to be time series data. So some date is there. Then you write temperature of this, right? Then you write what is it? Humidity, then rainfall. Here some date is there. Let's say what is it? 13 December, then maybe 12 December, then 11 December, so on. It will go right, and every day some temperature will be written, some humidity will be written, some rainfall will be written, and we are collecting the data of same place, which is Mumbai, right? Mumbai. We are collecting same place data, Mumbai. So the place is not changing. Actually, the days are changing, right? So time is changing across the data. The place is same, everything is same, even their instruments are same, everything is same, right? But we are collecting same thing, temperature on this day, right? Nothing else is changing, but temperature is changing, weather is changing according to time, right? So here time is an important factor. With that's why this is a time series data. This data, you can say this is a cross sectional data. There is no relation of time, right? When this Rahul is a person who maybe who is age of 37. Uh, he liked or he bought a shoe material of leather. Then purpose was formal, high price range was higher, and something he suggestions he gave, right? So this kind of thing is that there's no relation of time here. Time is not this is not bounded by time, right? This person bought this, another person came, he bought this at any time. There's no relation with time, so that kind of data is cross sectional. This is cross sectional. This is time series kind of data, right? Now, okay, this thing we already covered. Okay, what is it now? Okay, uh, this is related to the next question is related to relative frequency. Okay, relative frequency. So frequency is first, what is frequency? Frequency is the count of something, right? Let's say this data is there where I'm talking about gender, right? So let's say male is appearing, female, male, male, female. Let's say this much data is there. Now, if I ask you what is the count of male in this, you can say male are 3, right? Female are 2. Uh, so why do we do this? This is a good, if we have this kind of data, we can get to know other kind of things about it. That let's say how many percentage of females are there. So maybe you can do 2 by 5, right? Total by whatever available by total, right? So you will know that it is 40%. Then you know that male, how many males are there? Then you can do again 2 by 5, and you can say 60%. Yeah, so 60% male and female are there, and that's what this percentages which I'm mentioning. You can say that is also relative frequency, right? So if this male are there, female are there, right? So that the frequencies are, so that if I write that frequency, it's going to be 3 2, right? If I ask you what is the relative frequency, that is nothing but just the, you can say, percentage of it, or whatever this number by total, right? So 3 divided by 5, that is total. 2 divided by 5, that is total. So from this you can maybe you can get 0.6. Here you will get 0.4. Okay. If you write in percentage, it's going to be 60% and 40%. So anyhow you write, these are numbers. Just get to know the number. That this is frequency, this is relative frequency. So here same thing given, that frequency is given, relative frequency is also given. So how will you solve this kind of problem, that how many deaths happen in city hospital? So this is the summation they are asking, right? Total number of total they are asking to us to find. So the total is 150 plus x plus y plus 250 plus 300, right? So but we don't know what is x and y. But what we know, we know that yeah, what we know is that frequency is or relative frequency is frequency divided by total. Right? This thing we know. So if I let's say take x, right? Relative frequency is given to me, correct? So from this I can but does the total given to me? Like total is not given to me, right? So I need to take something where total I can find any one value of this, right? So I need to find any one value of this, then I can go to next step and then I can find another value, right? So how will I find that value? Here I know both of them. Okay, so here this thing, the two of them given to me, frequency and relative frequency. From that I can find the total, right? So if I put in this formula, what is the relative frequency? 0.3. What is frequency? 300. So from this, can I find the total? Yes, right. So I'll you know I'll bring here and I'll bring down here, right? So that's how this. How will you send something opposite side of equal to? If you're done this kind of mathematics, so total is 300 divided by 0.3. 0.3 you can write maybe 3 divide by 10. So like this you can write, and this is 1. So you get 1000 as total. So total is 1000. So this thing is 1000, right? I don't need to do actually x plus y. Uh, I found it, and this is 1000, right? Uh, you can do x plus y, but you need to find that. So if that is the kind of question is there where you couldn't able to find this total somehow, then maybe you can do it. Okay, x plus y as well. Okay. Now the question is, what is the value of z? Okay. So the issue is we don't know y, we don't know z, right? Both are variable. Uh, but what we know is we know total now. So let's see. Can we find x first? So that I can know what is y, because here for this row there is nothing I know, but for x I know something, right? That x is x value, which is frequency, is going to be oh okay. Uh, I'm putting in this formula only. Okay, so relative frequency is given to me, that 0.175 is the frequency of x, and I want to find the x, which I don't know, and I know the total now, right? Total is 1000. So from this, can I know x? X is going to be 175, correct? Now I want to find y, right? So how will I find the y? Y I can find as I know the total. Total is 1000, right? And I know what else this words are, right? So how much this part is. From this I can know what is y, right? So if I do 1000 minus all the summation, which is like 150 plus x. Now I know x, which is 175, right? So and then 250 plus 300. If I do this, I'll be able to figure out what is y, right? So okay, let's do this. So 250 plus 300 is 550. 550 plus 150 is 600 and 700. 700 plus 100 is 800. So 875 is the number of this total. And if I wanted to subtract 1000 minus 875, which will give 5 to 1, right? So 125 will be the value of y. So from this, so I know now what I know is x is 175. This is 125, and you can see the total will come out as 1000. So total will come out as 1000. So from this y I can figure out what is z, right? So z is frequency, which is 125 divided by total 1000. So from this I can know that this is going to be the value 0.125. Okay, fine. Okay. Any doubts so far? Okay, fine. Uh, okay, then we can move on. So just clearing the space. Now, what is this? If an analyst wants to represent the revenues of various companies using graph, then which of the following graphical representation is most appropriate for the purpose? The revenues of various companies using graph. Okay, let's see. So he chooses, let's say, pie chart with a pie is a slice of each company and the width corresponding to its revenue in crore. Uh, so when do we use pie chart? When we know the total of it, right? So if I know the total or the complete amount, then only I can do the pie chart. But here they are saying revenues of various companies, right? So what are these various companies? I mean, how which one I'll include, which one I don't include? Do I have the companies maybe in the world or something like that? Do I have revenues of their data? Most likely not, right? Most likely nobody has it. So I can't draw the pie chart, right? So pie chart will be useful when I have the whole data set. So let's say if I say 40% female and 60% male, right? So when I do this, then I can draw the pie chart that this is this is 40%, this is 60%, right? Or if I know, let's say, three kind of fruits being sold by uh, a person. Let's say he's selling apple, banana, and maybe orange. Okay, so this kind of fruits is selling, and only three kind of fruits is selling, right? So then I can draw the pie chart, and maybe I know the percentage of it. Let's say 10%, 30%, and then rest will be 60%, right? So this the in this way he is selling the fruits or something, right? But revenues of company of each company, like various companies, I don't know, right? So I can't do a pie chart of this. About the revenues, I can't do it. Okay. Let's say maybe company's revenue, how a company, I have revenue of the company, and I'm spending the revenue which is generating a company, right? Then I can do, maybe they are spending 30% on the employees, 20% on development, something, um maybe what is it, 50% on advertisement, or more, like, so various components could be there of the revenue, which this kind of studies I can do, but I can't do a pie chart of this. So this is not a true option. What is it? What is next? Bar chart with a bar of each company on x-axis and length of corresponding revenues. uh, okay. A bar chart with a bar for each company on x-axis and length of corresponding to its revenue in crore, right? So this I can do. This is company A, company B, company C, company D, right? I don't need to know how many companies are there, right? How many total companies are there? How many, whichever, whatever is there, right? I don't need to know that. So what I can do is uh, I can draw this kind of chart, right? So this is called bar chart. This is possible. Now a bar chart with a bar for each company on y-axis and length of corresponding revenue in crores and x. This is okay. Both kind of bar chart. This is called I think vertical bars. So this is vertical bars, and you can maybe draw horizontal bars as well, right? This kind of data is also valid. So horizontal bar chart, vertical bar chart, both kind of bar chart is okay. Okay, you can do that. A bar chart with minimum revenue as a baseline. Um, Minimum revenue as a baseline. So what does it mean by that? Is, let's say company A is there, which has, let's say, 700 crores revenue. Company B is there, which has 500 crores revenue. Then let's say something has 800 crores, right? So this three kind of this is there, right? So this is a data which is starting from zero. So this is my starting point, zero. From that I'm drawing the bar chart. You can see minimum revenue is earned by this B company, right? ABC. B company is earning the minimum revenue. What if I draw considering 500 as my baseline? So now my bar is starting from 500, right? Let's say uh, 500, right? So this is my baseline. Now if I draw for A, it will be 200. So this length will be 200 only, right? Length, I'm writing length here now. I'm not writing the revenue. So this length will be 200. Since I'm already starting from 500, this length will be nothing, 0, right? And then C will be it's a little bigger, 300 length, right? So I'm drawing in a lengthwise because we chose 500 as baseline. You can see this bar chart doesn't look good, right? This is you are kind of violating area principle. So you would have gone through the lecture. There is something called and area principle in the charts, right? That you should give uh, the space given to entity will be proportionate to the value it has, right? So it does have. So here you can see uh, uh, they are showing the values which they actually are, right? 500, 700, 800, which they actually are. So this is a good, you can say, representation, but this is not a good representation. This is a bad representation because you can see B company is kind of lost, right? There is nothing about B. If you give this data, nobody will even consider that B has any revenue or something, right? So this is like you are tempering the uh, charts, right? So that's why this is incorrect. So that's why B and C are correct and not A and D. Okay, fine. Okay, next question. Uh, Which of the following can be determined for both uh, nominal and ordinal data? Okay, so let's say name is there. I'll take the example. Okay, name is the nominal data. Let's say names are yeah. Let's take this example only. What is the issue? Okay, so this is my data. This I'll consider as nominal, and this I'll consider as ordinal. Right. So what are the things I can find about them? So that's what the question is, right? That out of mean, median, mode, what kind of which of the following can be find for both, right? So keep in mind that the question is about both, but we'll see what we can do, figure it out for the individual cases, right? So let's say this is the data. One is nominal, another is ordinal. Now for nominal data, what we can do? I can't order them, so that is out of the case that I can find median, because whenever we wanted to find the median, I want to find the middle value, right? The thing about middle, lowest, highest uh, is a position, right? So this thing cannot occur if there is no order. So without order, we can't find the minimum value, greatest value, or middle value, right? So because there's no order, so median is kind of middle value of this. So we can't do that, right? So ordering is not there. Now I'm still on this. Okay, can I find more mean? Mean is summation of the values. Because they are not values, I can't sum them. So summation is not possible. So I can't do that. So for categorical data, I can't do mathematical operations, right? Mathematical operations, I can't do that. But what I can do is I can only do counting in case of nominal. In ordinal, I can count. So this for nominal. In ordinal, I can count them and I can order them, right? So this is what ordinal data is. Yeah, so again we come to this column, name column. I can't do mean because I can't do mathematical operations on this numbers, right? I don't know what is Rahul plus Joseph is. I don't know addition of this. I don't know subtraction of this. I can't do that. So this is out of picture. Now what is mod? Mod is the count, right? Now comes the count part. How many let's say Rahuls are appearing in my data? Can I do that? How many Josephs are appearing? Because mod is based on count. Yes, I can do that. Right? I can do this counting. For example, let's say name is not. It might, if it doesn't feel okay, or doesn't feel, you are not feeling confident about the name column. You can maybe see this. Let's say purpose, right? This is also nominal data, nominal kind of data. So you can see, you can draw, uh, maybe you can draw bar chart of countings, right? That how many formals are coming up. Let's say how many categories are there. I'll just remove it. How many categories are there? Formal is there, sports is there, formal, sports, running. Okay, I'm just writing unique category. Okay, running, again running is there, so I don't write. Sports I already know. Formal I wrote. Sports. So this three categories are there. Now you can maybe write the count of it. So how many formals are there? One, two, or three. Right. So three were there, which are formal. How many sports are there? One, two, three. Okay, sports is also again three. I think they all are equal. So this is also three, right? So this is what accounts are. Uh, I can draw the bar chart and all. So generally mod is, or not generally, the mod is always with the highest peak, right? So if let's say sports was like this, the four one, then the sports would have been the mod, right? So we do the counting, and which has the highest count will be the mod. So in this case, this all are equal. So if this is the case, then we call it as, multi model data. Okay. If there are two only, then there is specific name for it, which is bimodal data. Bimodal data. But this is multi-model. More than two is multi-model. Okay. Usually one mod data is there, which you call as mod only, right? So single mod data. So generally we have mod of this thing, right? Because mod is based on counting. Median is based on ordering. So you can find mod using this count. Ordering, if you do, then you can find median. And mean is actually the mathematical operation. You need summation of it, right? So this is required for finding mean. Okay. Okay. Now, where was I? Yeah. Now let's see what we can do with this price range, which is ordinal data, right? So what we figured out that uh, this any nominal data, I I can't do mean, I can't do median, I can't. I can find mod. I can find the mod of it. Right. I can't find this too, but I can find mod of this. Mod of this. Okay. Now, what will be the case with ordinal data? Uh, Now you can see this too we can do, right. Counting we can do of this. How many highs are there? How many medium are there? How many lows are there? So we can find mod of it, right? Counting we can do. So mod is possible. Uh, Can we do ordering here? Yes, right. So order is there. So low, medium, hard, high. Low, medium, high is there. So three kind of orders are there. So we can do the ordering. So we can find the median, middle one, right? So if let's say data was uh, low, low, high, high, low, low, medium, medium. This kind of data is there. What I would have done is I would have arranged them according to their order. So I would have gone from low to high generally. So if I do order them low, low, then this two, then medium, then high and high. Then what I would do is I find the middle value of this. So there are four and four. So you can see this two are middle value. So you can consider any of them as a median, low or medium, right? So any of them can be a median value, low or medium, right? So medium and median. I'm talking two things. So this two, both of them can be median. Okay, and this is related to M. I will just call M. Okay, so this is how data is that L and M both can be median. Um, so in ordinal data, I can do counting, I can do ordering, so I can have mod and median. In normal, I can't do addition again, right? So because I don't know what is high plus medium addition, or low plus medium, or low plus high addition, right? If I add them, what value going to come out, I don't know. So this kind of thing is not. So for ordinal, I can uh, I cannot find mean. I can find median of this, I can find mod of this, right? So these two are possible. The question was the previous question that what we can do about it. So of both of them, so on both of them we can find mod. Okay, on both of them, uh, this question was there. Both nominal and ordinal data, which of the following can be defined? So mod is the possibility here. Okay. Okay. I'll take the next question. If anybody has any doubt, you can raise. Okay. Uh, then I can start. The share of Indian telecom market is plotted as the pie chart shown in the below figure. Okay. Uh, is pie chart misleading? How would you know pie chart is misleading? Is you sum this all entities. It should be equal to 100%, right? It has to be. That's what pi means. Some share is of entity, right? So what I'll do is I'll sum this all three: 37, 27, 27, 9, right? So sum is 7, 3, 21 plus 9, 29 plus 30. So 0, 3 here, 6 plus 4, 10, right? So this is, yes, this is actually 100%. So graph is not misleading. The pie chart is not misleading graph. That is correct. Four possibilities are there, and all four of them are mentioned in the chart, and the sum of the pies are coming out to be correct, like 100%. The pie is misleading, which is not. This is the opposite of that. So pie chart has round of errors. No, there is no errors, right? Round of errors means like generally here the pie chart is coming out to be correct, like integers, right? But sometimes what happens, pie chart is coming out 25.55%, 30.20%. So in this cases, still it has to be 100%. Okay, because otherwise, sometimes what happens if you remove this portions, just 25, 30, and all, you'll see that maybe 1% is missing, right? Something like that could happen. So, but round of errors are not there because we have integers only. The slices of pie chart do not add up to 100%. It does add up to 100%. We did it. Mod of the data set is reliance. So mod, we can find it. It is a nominal data. Four kind of companies are there, and which has the highest share will be the mod, right? So highest will be the mod. So which you can see highest, others, and numbers are also there. So this is mod. Okay. Can you find median of this? No. Median is not possible, right? Because you can't order them. If you can't order them, you can't find median. Okay, so bar chart is there. This kind of data of different subject. This is a nominal data, right? Because you can't order subjects. There is no priority of order. When you give an exam, every subject is equally important, right? Or even like it is equally important otherwise also. Okay, bars are not arranged in increasing or decreasing order. Okay, that is not the question. The question is uh, uh, the bar chart given in the following figure is misleading. So this is misleading graph somehow. And why is that? Because why? Because bars are not arranged? No. We can have bars in any way. It doesn't have anything. Though there is one good way to represent the bars is Pareto's chart, right? So if you order them in an increasing order, this is decreasing order, or in increasing order also. This is a good way to represent a chart. This is a Pareto chart, right? So this little if you arrange the bar chart, it becomes Pareto. But that doesn't mean that bar chart is incorrect, right? Bar chart is correct, right? Because we know that from data that this is 91, 45, 89 and all. So we know that data is correct. It's not misleading to us in that way. The baseline is not starting at 0, right? That might, or that is the kind of reason looking like misleading, right? Because it is not starting from 0. You know that when we did this part, which question was that? Thing related to this company, right? Yes, they're related to this pie chart company and all, right? That bar chart with the minimum revenue as a baseline. if I don't keep it, you know that, right? Let's say if I start from minimum value, then you know that one company was completely disappearing from that cases, right? So this could, if you don't choose baseline as 0, this uh, problem can arise, and this is what we are seeing here. So maybe if you can see, that's a 34 and 45, they are not that much uh, far away, or are they? But they're looking more far here, right? I mean, you can see maybe here it is more concludable that uh, baseline 0 is very important case, right? So baseline 0 is the reason that this is misleading. What other could be? Subjects are not arranged in alphabetical order. That is not required. This is not a there's no order in subjects in between or something. So that is not required in cases. The bars are not misleading because the width of the bars is same. Width of the bars should be same. This is a good way, uh, but is not misleading. Not misleading because the width of the bars is same. I mean, the statement is true, but they are asking about why is it misleading, right? So we don't care about this. Okay, manipulated y-axis. Uh, Manipulated y-axis. Mm, that is not uh, that is not true because we are not we're not manipulating y-axis. So how does manipulating of y-axis looks like this? Like you maybe start from 0, then this gap is equal, right? 20 to 40, this is 20, this gap is 20, this is 20, this is also 20 till 100. What you can start is, maybe you can start at 0, then another line is like at 10, then maybe another line is at 30. So gaps are not equal. If these gaps are not equal, then maybe you can say that is manipulating y-axis, right? uh, that I'm not having equally distanced uh, equal distance values in y-axis. Okay, so that's why it is also not correct. Okay, leaf plot. So how do we actually see leaf plot is? So we always first, whenever leaf plot is given, always look for this thing, that how does this leaf plot representation looks like, right? So that this leaf plot means this, how, right? That 1 and 0 means 10 lakh. So this is 10 lakh. Another, so what are the values here in first row? If I tell you, according to this representation, keep in mind, if representation is different, then you have to think in that way, that what does it mean, right? So it is always given, how does this representation of leaf plot you have to take. Okay, so in this first row, the data is given to me 10 lakhs. Okay, then 12 lakhs, 1 from here, 12 from here, so 12 lakhs, then 16 lakhs. Okay, that's what the representation means. That take this value and this value, not adding. I'm not adding them. This is not 7 lakhs. This is 25 lakhs. I'm concatenating the numbers, right? So this is, you can maybe say this is a value of tens place, and this is at unit place, right? So 2, 5, and that many lakhs, and then again this all at 25 lakhs, right? All of them. This guy is 30 lakhs, then 32, 34, 41 lakhs. So this is the kind of data I have, right? 41 lakhs. This is the kind of data I have. And now what I need to find is, what is the average annual package of the student if each observation is doubled after subtracting 5 from it. Okay. What you can do is, either you can do double of each of them, uh, then maybe subtract 5 from it also. So they means subtract 5 means 5 lakh, right? 5 lakh from it. You can do that, but that is the inefficient way. It will take more time. You first need to double it, then you need to subtract it. What we know is, they're asking of average annual package after doing this, right? So we know from the property of mean is, if any mean is there, if you add a constant to it, and so if you add constant to all the values of number. Let's say we have how would I write n1, n2, n3, n4, and 5. This 5 kind of values are there. Now what you can uh, let's not try, but x1, x2, x3, x4, x5. Right? So this 5 kind of values are there. If you multiply each of them by a constant, let's say a is the constant, ax4, ax5, right? So if you multiply each of them by a constant, the mean will also, so let's say this was mean, right? The mean will also multiply by that constant, right? This much time, this is the new mean, okay? Mean new, say new, right? So this will become new mean. You will multiply mean by that constant and that you will get it. Now if you add a constant to it, let's say b is a constant in each of them, then mean will also get affected that much. So a times mu times the constant, right? So what I will do is I'll first figure it out. What is the mean of this data, which is already given to me, and then I know what I have to multiply. I have to double them. So I'll multiply two of them. Then I'll subtract 5 from them. I have written positive, but you can maybe see, like, let's say positive minus 5, right? So this thing you can maybe think that b was negative value, right? So you can write b as positive or well negative, right? I never said b should be positive. So like this, if I do, then I'll know the the correct answer. Basically, it will come to this value. Okay. So let's see what I can do. I have to first find the addition of this. So I'll do 10, 12, 16, then 3 times 25. Just in case I'll write like this. Then I have 30, 32, 34, 41. Okay. I need to add this. So what I'll do, I'll write this as 75. Uh, yeah, better. Now let's see what is going to be this. This is 2, 6, 8, 8 plus 5, 10, 13, 13, 15, 15 plus 5, 20. So 0 and 2 as a carry. 2, 3, 4, 5, 5 plus 7, 12. Yes, 12. And then 15, 18, 21, and 25. So this is 250. So I got 250 as the summation of this. How many other? Uh, 3, 3, 6, 3, 9, and 110. It's a total 10 other. So mean is 250 by 10, which is 25. So this is my the mean of my data, which was not being changed yet. This now I'm going to do some changing in that. I'll double each observation by 2, right? So I'll do this, and basically I need to find this, right? So 2 times 25 minus 5. So uh, oh, sorry, I didn't read it same way. So each observation is doubled after subtracting 5 from it, right? So then I need to, like, uh, first subtraction, then uh, multiply it by 2, right? So I had 25, I'll subtract 5 from it, then I'll multiply 2 to it. So you'll get 40, right? Which is the correct answer. So that's how you can do it. That uh, so adding constant, multiplying it, you can do this way. Next question. What is the population variance of given data if 5 is subtracted from each observation? So they are talking about this data, okay, not the altered one. This data is there. What is population variance? So how will you do the population variance? We know that mean is 225. Sorry, we already found this. Now I want to find the population variance of it. So mm, uh, if 5 is subtracted from each observation. What is population variance of the given data? 5 is subtracted from each observation. Actually, subtraction will not change anything about variance, right? So variance will be same even though you subtract from anything from it. If you do multiply, then it will affect, right? Let's say you had let's say if I plot this 3, 4, 5, right? So this was the value, and one sorry, -1, this is 1, this is 2, -2. This was the variance of something, right? If I subtract 2 out of each of them, I mean let's say this much is the variance, right? So you can imagine variance as this much, that this much is the variance of data, like let's say 2 is the variance of data. This is just pictorial, this don't take this number as actual one. If I subtract 2 out of each of them, then what will happen? It will become -4, this will become -3, this will become -1, 0 minus, sorry, 0 minus 2 is -2, this is 0, this is, if this was 1, right? So -1 minus, this is 0. This is how it is. And you can see the nothing changed actually in this, right? You can try it. You can plot this data as this thing. You can maybe find the variance of that, and you can subtract 5 from each of them. So that will not change. But we need to find what is variance, right? That is the task we have. So how am I going to do? I'm going to do this way. So 10 minus 25 square plus 20 minus, or sorry, 12 minus 25 square plus 6 minus 25 square. That's how you do it, right? So 25 minus 25 square. So there are 3 zeros. I'll just not write it because 25 is the mean. Then 30 minus 5 square plus 32 minus, sorry, 25 square plus 34 minus 25 square plus 41 minus 25 square. And then all of this divide by, since it's a population, I'll divide it by n, right? N is 10. I'll not do n minus 1 because it's about population. So yeah, I need to figure it out. So it will require calculator. So if you do this calculation, you'll get this. Okay, this based on calculator. So you have to do this. Okay. Next question is, okay, out of 50 of 5 students in chemistry and biology paper, okay, two exams are there, and 5 students marks are represented in this way. What is the correlation coefficient between the marks of both the exam paper and this side? So they are asking about correlation coefficient. So correlation coefficient is represented by R, which is covariance of two entity. So here you can maybe say chemistry and biology, right? And divide by what? Standard deviation. You can take anyone, sigma or S. So sigma is basically population standard deviation or sample standard deviation. Doesn't matter. You have to take you just because it will get divided by covariance, right? Covariance also has denominator as that, right? So you take both a sample, either sample covariance and sample standard deviation, or you go with population covariance or population standard deviation, right? So this is like, let's say for chemistry, I'll find the standard deviation, I'll multiply with the biology standard deviation. So this thing you have to do, and you can get it, right? So, and covariance, if you don't know, covariance is, let's say I consider this as x, this is y. I'll take x. I'll figure out what is the mean of this. So I'll represent it as a bar, x bar, and this also I'll compute mean of that, which is y bar. So I'll take that, this thing, and then y again I'll take minus y bar. I'll multiply both of them. Okay, I'll multiply both of them, and then I'll take summation of that, and I'll divide by n minus 1 if it's a sample. If it's population, I'll divide by n. Okay, that's what is covariance. And from this, you know that what is standard deviation? Standard deviation is x minus uh, x bar whole square summation divide by uh, n minus 1, right? If it is a sample. So this is what it is. This is uh, another entity. So you know that this and this will get cancelled if you use this formula. Okay. Uh, and you can do this, right? This question will also require you to have calculator. Okay. So can I do it? Wait, what is x bar? X bar is I have to add them and divide by 5. So 20 plus 25 plus 30 plus 35 plus 40. 150 divided by 5, which is 30. So this is coming out to be 30 plus this 25 plus 20 plus 30 plus 20 plus 30. So this is 125 and divided by 5 is reduced. So this is what it's coming out. Now you have to figure it out what is standard deviation of this, which you can do like this 20 minus 25 whole square and so on, right? Let's say this first one is for x, right? Standard deviation of x is I'll do 10 square plus 5 square plus 0 plus 5 square plus 10 square, right? And divide it by 5. You can figure out this. This is 100 plus 25 plus 25 plus 100 and divide by 5, which is 250 by 5. So 250 by 5 is 150. That's what it is. So that's what standard deviation of x is, 50. I'm using calculator, so just in case. Now I'll do with the biology. With biology, this is 0. This will be 5 square. Again, I have 5 square. Then I have 5 square. Then I have 5 square. And I'll divide with 5. So I have 4. Sorry? You are not audible. You are not. You are audible, but you are not able to understand. Okay. Any doubts? Yes. Is this standard deviation though? Standard deviation. No, this is just, sorry. I think I missed it. This is just a variance. This is variance. You have to take under root of this, right? So you have to take under root of this. You have to take under root of this. Okay? Then you'll know what is x and xy. Then with covariance, you have to, what you have to do is this last question, so I can maybe write here as well. You have to do is you have to subtract mean from each. So let's say 20 minus 30 is 10 or even minus 10. Then 0 plus this is minus 5 and 20 minus 5, 25 minus 5 plus 30 minus 30 is 0. So something will multiply will also become 0. So no need to write. Then 35 minus 30 is plus 5 into minus 5. Then I'll have plus 10 and I think plus 5. This is minus 5. This will be also in my 5. This next from 0, 0, low. Okay, fine. This is what it is. This will become 0. This is also 0. So we have 25 minus 5 into 5 is 25 minus this is also 25 plus this is 10 into 50, right? So that is 50. So you will get 50 as a not yet. You have to divide it by you can choose n minus 1 or anything, but I chose here this thing, right? 5. So I'll choose 5 only because I'm considering population covariance. So I'll divide it by 5. And yes, this is what it is. So this is covariance 50 by 5, which is 10. So if I do 10 divide by root of 20 and root of 50, or if I write this way, this will be what? If I find what is the root of 50, I can do root of 50 into 20, which is so this is 10 into 100, right? So we'll get 1 by root 10. So if I figure out the 1 divided by root of 10, which is 0.316. So it's coming out to be 0.3162. Maybe you can make it to 0.32, which is what the answer is. So so to summarize, what I did is I first find the mean of both, right? Then maybe you can say I figure out first what is standard deviation. You can go with covariance also. So covariance I'll figure out, which is x minus x bar into y minus y bar. Summation of this I did multiplication with summation. So that's what I did here, and then divided by n or n minus 1. Your choice. You either you take sample or you take population. Uh, Nothing is mentioned, but because correlation coefficient is not affected by sample or correlation, this will get divided. This will get uh, neglected in that, right? Then I have to figure out what is x, which is standard deviation. So you will get from variance of this under root of this, right? Variance of x and under root of that. Then I figured out this and under root of that. So this came out to be root 50. This came out root 20. This was the whole thing, right? Covariance came out to be 10. Okay, this was 10. And correlation coefficient is correlation coefficient is covariance of x comma y divided by standard deviation of x, standard deviation of y. So according to that, I did this root of 50, root of 50, root of 20. And this came out to be 0.32. Okay, so that's how I figured out what is correlation of this. Okay, one thing is missing in this, which is how will you find calculation will be integrated in the on the server wherever you give the exam TCS center, and it will be there. Calculator will be there. One thing is what is point by serial uh, correlation. Okay. So yeah. So this will be useful when we have one as categorical data and one is numerical data. Okay, so in this cases we use point by serial thing, but there is one condition that category has to be binary only. So there are several things which as binary, right? It's a true false is a binary case. Something is true and false, right? Uh, I don't know. Have you had breakfast today? So true false, right? So that kind of variable is there. If it is right, on off could be there. Is fan or is electricity there, on off something, right? So on off you can maybe say maybe yes, no, true false, high low. If this is the there, right? If two categories are there, then you can do it. If there is high low medium, then you can do it. Then point by serial will not work. So the by in itself is like related to by, right? That has to be two only. If this kind of categories are there, then you can do it. Okay. So let's say just an example for this. Let's say for example was mm, serial so what we are gonna do for this is represented like this point by serial. What we do is first we figure out mean, sorry, not xi, mean of the let's just take some data, then that would be much better. Otherwise that will be complicated. This is okay. Okay. So this is a exam result data. Okay. So here it's mentioned what is somebody has passed or failed, right? So that's what it's mentioned here. So let's say failed or pass. Okay. Fail. So I'll just write F for this and P P P F then P. Okay. So let's say this much data is there for categorical type. Two categories are either pass or fail. Okay, then I just if somebody's confused, this F is fail and P is pass. Okay? Not more than that categories are there. Let's say their marks were 2, 3, 16, 17. Okay. Doesn't look like 3 is failed and 16 is passed, but I don't know, some kind of data. 5, 6, 14, 7th. Okay. Maybe better to let's say this is rather than pass well, let's say this is gender. Okay, gender of just male and female is there. Let's say just remove this and write, let's say male and male. So you can consider F as female and the rest is male, right? So what we are trying to do is we are trying to figure out what is correlation between female candidates who wrote the exam, right? How much score they did or how much marks they got and how much marks male got, and are they, are they kind of correlated? uh, I mean, either does gender has effect on score? That's what we the question is. Does gender have effect on marks? That's what you wanted to figure it out, right? And generally, if both are let's say numerical, then there is no issue. You can plot this scatter plot, and you can say, okay, yeah, that there is a correlation, there is covariance. There's something you can do with it. But when two categories are there and then marks, then how will you do it? So you have to figure out what is this point by serial correlation coefficient. That is, you first consider a mean of first kind of class, let's say male, you'll take, and then female. So generally we choose here which has higher mean. Okay, higher mean value. We'll consider here. Okay. Um, Generally we do that. We don't want this to be negative value. You can have it in negative value, but you have to interpret it like this. When somebody will ask you, you have to say it that it was female. Yes, just like it was positive, but something you have to explain. So either you make it positive and then you don't need to explain much further, or you can directly say that yes, gender is this much correlated with the marks. Okay. Then you have to figure it out what is standard deviation of the numerical one. So this numerical, or here we have marks, right? So you have to find the standard deviation of marks, and there is another multiplication is there, which is like proportion of male and proportion of female. Okay, if somebody doesn't know what is proportion, so let's say this was the pool, this is female, let's say this was male, and let's say this is 35%, this is how much, 65%, right? So this is what proportion is. Proportion is you write 35 divided by 100 and you get 0.35. So this was, you can say, proportion of female. Okay, that's how you can figure it out. So proportion is the percentage of how much it does represent, right? That's what P of male and P of female means, proportion. You can figure it out that you have, let's say, total n, right? So how many we had? We had 1, 2, 3, 4, 5, 6, 7, 8. We had 8 total. So n equal to 8, you can say. And how many females are there? 1, 2, 3. 3 females were there. So 3, right? This how you can. Okay, this was related to male, so I'll write 5. 8 minus 5, right? This was 3 by 8. So by this you can find the proportion, and you don't need to this side. So what I'm doing is I'm just writing whatever numbers are there, and then n1 by n and n2 by n, where n1 plus n2 is n. Okay, then only this will work. So this thing, if you do, then you can find the point by serial correlation coefficient. You have to figure out what is the mean of male. So if I see what is the mean of male is 3 plus 17 plus 5. So I have to sum this 3, 17, 5, then 1, 2, 3, 4. Oh, only 7 are there. I maybe miss 4 by 7, 3 by 7. I maybe miss calculator. So yeah, then 1, 2, 3, 4, 7, right? So I have to find the mean of this, which is this is 10, this 17 plus 5 is 22 and 32. So 32 by 4 is going to be 8. So 8 is the mean of this. So I'll put into the equation, which is 8, right? X mean of male, then mean of female I'll find of this value, right? So consider I'm considering this values, but I'm also considering which category I'm also looking at. So I'll find for females only, right? Mean of that value, mean of this values, but related to the females. So which is 2, then 16, then 14, which is this is 20, 32 by 3. Oh, this also has 30, 20, 30, 32. Yeah, so this is going to be 32 by 3. This is 32 by 4. Much, there's no easy. Both are similarly. Then I'll write standard deviation of x. How will I do that? I'll find the total mean. Then I'll do so I have to find xs, which you can do, right? You know how to find the standard deviation. I have to write this thing, right? X1, x2 minus x bar whole square, so on, and then divide by um uh, so we mentioned, okay, sample or population. So whichever is given, write n minus 1 or n accordingly. You can find it, and then you have to write proportion, right? Which is 3 by 7 for female and 4 by 7 for male. So if you do this, you can get the point by serial correlation coefficient. If it is mentioned here, no, it's not. So this thing you have to figure it out, and you'll get this value. Okay. So this was the last thing. That's all from my side. Is there any doubt?
Hello.
Yeah, hello.
Yeah, hi sir. I have a couple of doubts. I mean, about the whole thing actually. You might have mentioned it before, but can you just tell me that remaining sessions are going to be the same, or like are we going to discuss different papers in those sessions? And like, can we get like PDFs for all these papers we have just discussed?
PDF is okay. We can send you through mail. PDF. So this question PDF will be there. You can get it.
Okay.
Or what you can do is there is one thing I pasted in the link. A link is there. If you open that, there will be several question papers of previous term. You can have that.
Okay. Okay.
So you just have to select statistics one course in that. They will ask which course or something like that. It will be there.
Okay.
Uh, so you have to choose the that thing. Right? If I, yeah. So if I open this, you can see it will ask me which. So maybe you can choose end term quiz. So for you there is no end term. You just have one course, but our course foundation course has quiz 1, quiz 2, and end term. So for that this is there, but for you it's not specifically not there. But you will have similar kind of question. Okay, there will be no difference in it. Just you don't have in similar proportion of end term. You will have questions from all the week. So what you can do is you can go to quiz 1, prepare. You can go to quiz 2 and then solve it, and then also and consider end term also. So all three of the papers you have to check. You will see equal proportion of all of the weeks. Okay, almost equal, like not exactly equal, approximately. You have to choose statistics one course. So statistics is one course. This is the one, and then this other, you can start any of this. You here have will have this kind of questions, like suppose A and B, write the probability, which is in next weeks. This thing, write the probability, this thing, something, right? So you'll see higher question of probability and term, because that's what has higher weightage in the course structure, but not for you. Okay, will not have that much probability. I mean, it does have, because after let's say week 7 probability starts, and rest of the weeks are probability only in some way. So you can consider probability as higher weightage, but you'll have some higher weightage of earlier week 1 to 4 as well, not this much. Okay, so you can try. Maybe solution will be not there, but answer will be there. So I'm not sure how to um, give you solution. Check answer. You can check answer. So accepted answer is 0. You can do this way. So answer you can check. Let's say for this you wanted the answer. Check answer. So there's 2 are answers. So you can do this. Different questions are there. Statistics 1. Uh, 1 is here, not 2. Okay, 2 will be higher level than this. Maybe you can try. Oh, sorry. Let's try. You can go to quiz 1, then write statistics 1, and then you'll see the similar question which we did today. So this analyst descriptive, what is a descriptive study, or what, find the standard deviation, or what kind of bar chart is this, find the mod of data set. This is what we did today. Okay, similar to that, because this is from week 1 to 4. Find the, what is it, um, relative frequency from this data which we did today. Find the covariance which we did, right? So these all questions will be almost similar to this. You can practice from this. Okay. Yeah.
Okay.
Anything else?
Yeah, and about the remaining sessions, like, are we going to solve the same question set, or are they going to be different?
So uh, I mean, generally we do this way, but we are uh, open for any other advice, like any other thing you want.
No, no. I mean, I was asking like, these are the same type of sessions where we will solve the same exact question paper, or the question paper and PIQs will be different for the rest of
No,
session.
no, it will be different, right? Because now this is from week 1 to 4. Now
Okay.
you'll have week 5 to 8 in next session.
Okay.
So the questions will be different.
And can we get the recordings of this session?
Yeah, it's there. Uh, so it's already shared in the chat. I'll share it again. So this is the recording. It will be on YouTube.
Uh,
What has been discussed? Yeah. So we discussed what is the content of week 1 to 4, which is like what is like population, what is sample, what kind of scales of measurements are there, how to find mean, let's say median, mod, uh, what kind of uh, how to find frequency, relative frequency, then covariance, variance, not variance, correlation, point by serial correlation. This is what we covered today.
so this
Week
was
one
the
to
first.
four of Yes. This is the first session.
Actually, I got the mail like an hour ago. That's why I missed out on it.
Earlier announcement was sent, right? I think it was sent 2 days ago with the timetable or something.
No, I have
Then
not.
okay.
Yeah,
Uh,
me neither actually.
Even I
mm,
didn't receive.
oh, is it? So you received this mail today only of session.
Yes, yes.
Okay. Then I'm not sure, but somebody else is responsible for this, who sent this announcements and all. I'll check with them. But you would have received a timetable something now. Is it now? Now you have received. When will be the next session of statistics then?
Uh, yeah, we have received a timetable. Yeah, today is the first session, which was I think this session, right? 6
Yes,
p.m.
yes, yes.
On, on 16th there is a session, and on 20th there is a session on statistics.
On
Yeah.
20th you have. Yeah,
20th December.
yeah, yeah.
Again on 16th we have one session maths. Okay, maths we have now. It has been mentioned. Okay,
Yes,
fine.
you have now. No, not today. On 16th you have, I think.
Sorry, 16th. So will we get a recording of this session?
It's already there, right? I posted this link, last link. You can see YouTube is the recording of this.
Okay, understood.
You can see the in chat YouTube or something, that is the recording for this session.
So so
So
for this session we can refer this one, right? This YouTube.
yes, you can refer this YouTube. That's recorded.
Okay, fine. Sure.
I have one doubt with the question of steam and leaf. Could you just clarify it because my answer
Sure.
happens to come at come 41.
Uh, this one only or different?
Yeah, same.
Okay. This one, right? You
Yeah,
so you're saying your answer is 41.
yeah.
How much is the mean of this? What mean you got for this?
410 divided by 10.
No, for this. This was 250 by 10. I mean, the summation is coming out to be 250, not 410. See, I did it here. You can see this. The 75 is 25 plus 25 plus 25. This three terms. Okay, so I wrote together.
Okay,
So if you do this, I the summation is coming out 250, right? And then 10 observations are there. So the mean is 25. So uh, the regular mean is 25. Then I have to do something with it, right? That I have to if each observation is doubled after subtracting 5. So how will that affect the mean? That's what the question is. So my initial mean is 25. I subtract 5. Uh, yeah, 5 from it, and then I double it. So if I do same thing with all the values of my data set, then the mean will also affect in similar way. Okay, so that's why I'm doing this. That this was my mean initially. Uh, like you can say mean or mean initially, right? Okay, then I'll have new mean, which is this. Okay, this will be my new mean. I do this. So 25 minus 5 is 20, and into 2, which is 40. That's how this answer is coming up. Not just this average. And
no,
the
because
summation is not
uh,
4.
what I did was I took all the numbers and I subtracted 5 from it and then
5.
I doubled it and then took mean of that.
Uh, okay.
Yeah,
So
and
you are saying your sum is coming out to be
410.
410.
Yeah,
Um, okay, give a minute.
yeah,
We can verify that.
sure, yeah.
So uh, I need spreadsheet. Okay, so let's see. The data was 10, 10, then 12,
10, 12, 16,
16,
25, 25, 25,
25, 25,
30, 32, 34.
30,
32,
32, 34,
41.
41. Okay.
Yeah.
Now I need to find the average of it. So I'll write.
We don't need the old average, right? We can
Yeah, we
directly.
don't need,
Hmm,
but let's just do it. And if
okay.
there's something missing or uh, yeah, so it is 25. I mean, there's no mistake there. Now, what I need to do is I need to subtract 5 from this,
Right.
right? So which will be I'll take this, subtract 5 from this. Okay, and I think it's correct. 7, 5. Yeah, that is correct. Now, okay, subtracted 5. Uh,
Now double it and take mean of that, right?
Correct. So what is it? The average. Does if which of those is double after subtracting 5 from, yeah. So now I'll double it. So how will I double it? I'll take this times 2. Right. So this is what it is. 14, 22. Yeah, it is coming out to be correct. Now I have to take again average of this, which is, it is coming out to 40 only, right?
Yeah, sorry, I miscalculated it. Sorry. Yeah, it's
Okay.
40 only. Yeah, my bad. Sorry.
Okay. Anything else? Um, okay then. If no doubts, we are closing the session. Thanks for joining. Next session will be on 16th. Okay. I'm stopping the streaming. So YouTube link is available in the chat. You can have it.
Yeah, thank you. Yeah.